Today, we will be designing a combinational logic circuit using Programmable Array Logic, which is PAL. We'll be working out 2-3 examples, out of which this is a first example, and the link for the rest of the example is available in the description box. So now let us convert a BCD code to XS3 code and implement this logic using a PAL. This is what we are going to do. To do that, first one is to create a truth table. So right now our question is to convert a BCD code into XS3 code. So we very well know that BCD code starts at 0000 and ends at 1001. That is from 0 to 9. So this is the BCD code and it is all 4-bit wide. And then we have to convert this code into XS3 code. What is XS3 code? Whatever it may be, with a given value we have to add 0011 along with it in order to get the XS3 code. Let us follow the steps and convert the BCD code into XS3 code. So first, what is a BCD code? It is 0000. We have to convert this into XS3. Let us do that. So 0000 plus 0011. So 0 plus 1, 1, 0 plus 1, 1, 0 plus 0, 0, again 0 plus 0, 0. Therefore, 0, 0, 1, 1 is the equivalent XS3 code. In the same way, let us do for the second one. It is 0, 0, 0, 1. So, 0, 0, 0, 1 plus 0, 0, 1, 1. When we add, 1 plus 1 will give you 0 with a carry 1. Again, 1 plus 1 will result in 0 with a carry 1 and 1 and 0. Therefore, 0, 1, 0, 0 is the XS3 code. In the same way, let us do for the last one, 1, 0, 0, 1. 1, 0, 0, 1. You have to add 3, 0, 0, 1, 1. What happens? 1 plus 1 will be 0 with a carry 1. Again, 1 plus 1 will yield 0 with a carry 1 and 1 and 1. So, this is 1, 1, 0, 0 is the XS3 code. In the same way, we have to fill for the complete table. The same thing is being done and digitized here for clarity. Now we'll move on into step 2. The second step is to plot a KMap. So in KMap, we need 4 input variables because it is a 4 variable KMap. The inputs are B3, B2, B1, B0. We have 4 input variables, therefore we are going for 4 input KMap and we are trying to find the expression for E3. We have to plot all these contents into the KMap. Let us do that one by one. So at 0th position we have 0. At first position we have 0. At second we have 0. At third we have 0. At fourth we have 0. In the position 5, 6, 7 we have 1, 1, 1. So 5, 6, 7 we have 1, 1, 1. And at 8 and 9 we have 1 and 1. At 8 and 9 we have 1 and 1. So therefore we have plotted all the values available in E3 and for the rest of the value we will be just marking with a don't care. So now we have to group. When we look at the grouping, it is possible to make 3 groups out of this one. This is a first group and here is a second and here is a third. While writing expressions for all these group, let us concentrate on the first group here. We have grouped all these 2 rows together. So when we look into the row, we have 1, 1 and 1, 0, which is nothing but B3 and B2. So B2 is varying because it is 1 and 0, therefore we cannot consider. Let us take B3. Therefore B3 becomes the expression. And similarly for the group that is highlighted with green color, we have to consider these 2 rows. So 0, 1 and 1, 1. So B3, B2. B2 does not vary. Therefore, we will take B2 into our expression. And similarly, when we consider these 2 columns which are common for this group, the column holds 1, 1 and 1, 0. That is B1, B0. B1 is not varying. Therefore, we are taking B1 also into the expression. And similarly, when for this group, highlighted with a brown, we have to consider the row which is 0, 1 and 1, 1. So 0, 1 and 1 1, which is nothing but b3 b2. So while considering this one, b2 does not vary, therefore I am taking b2 into the expression. And similarly, when we consider column wise, it is 0 1 and 1 1, therefore this second bit does not vary, which is nothing but my b1 and b0. b0 does not vary, therefore I am considering b0 into the expression. Therefore when you write the final expression for v3, you have to add all these terms together. So which is nothing but b2 b0 plus the second term b2 b1 plus the third term b3. All these three together gives the final expression for E3. In the same way we have to do for E2, E1 and E0. Let us do it one by one. Now here is the expression for E2. So again it is the same 4 variable KMap because we have V3, B2, B1, B0. And right now we are concentrating on E2. In the same way, what is there at the location 0? M0, M0 is 0. Therefore 0. M1 is 1. M2 is 1. M3 is 1. M4 is 1. M5, M6, M7, M8 all are 0. Therefore 0, 0, 0, 0. M9 is 1. M9 is 1 and the rest of the terms have been marked with don't care. So after looking into all these mapping, let us try to group once. We can see 3 groups. One highlighted with the green, other highlighted with the black and other highlighted with the dark red color. So these are the 3 groups available. So let us try to write expressions for every group. When we write it for the one highlighted with green, what are the 2 rows that we have to consider? 0, 1 and 1, 1. 0, 1 and 1, 1, which is nothing but B3, B2. B2 is not varying, therefore we have to consider B2 in the final expression. And similarly, when we consider this column wise, it is only 0, 0, which is common for 1 and this don't care. Therefore it should be B1, B0, but both are 0, 0. Therefore it is B1 bar, B0 bar. Next we have to consider expression for this grouping which is highlighted with a black color. So let us do that. What are the rows that we have to consider? 1, 0 and 0, 0. So I am writing 0, 0, 1, 0. When we look into this is B3, B2. B2 does not vary, but it is 0. Therefore this becomes B2 bar. So we are writing B2 bar. And when we consider these 2 columns together, it is 0, 1 and 1, 1. So which is nothing but B1, B0. Therefore B0 is not varying. Therefore we are considering B0. So when we look into the third group holds 0, 0, 1, 0. So again 0, 0, 1, 0. B2 does not vary. It is 0, therefore it is B2 bar. When we go for the column consideration, it is 1, 1 and 1, 0. These 2 columns are common to this group. That is 1, 1, 1, 0, which is nothing but B1, B0. So when we look into B0, B1 is not varying. Therefore we are taking B1 for the term. So when we write the final expression for E2, we have to add all these terms together, which is nothing but B2, B1 bar, B0 bar plus B2 bar, B1, B2 bar, B1 plus B2 bar, B0, B2 bar, B0. This becomes the final expression for E2. In the same way we have to do for E1. So again the same 4 input variables B3, B2, B1 and B0. Let us plot one by one for E1. At M0 we have 1 followed by 0, 0, 0 and 0. Then we have 1 at M3. Again it is 1, 0, 0, 1. So 1, 0, 0, 1 and it is 1 and 0. So 1 and 0. For rest of the terms we are marking with the don't care. So when we look into the grouping, we have 2 groups here. So let us write expressions for one by one. Now first let us look into the group which is highlighted with green color. We have 4 rows, but there is no one single term that is common for all these 4 rows. Therefore we cannot consider any term from B3 or B2. So we are dropping these 2 variables. When we look into the column, it is 0 and 0. Therefore 0 and 0, that is that variable B1 and B0 is common for all these 4 terms. Therefore let us write it as B1, B0. It is both the terms are 0, 0. Therefore it is B1 bar, B naught bar. So B1 bar, B naught bar. And now the second group, similarly when we look into the rows, none of the rows, like we don't have any common variable covering all these 4 terms. Therefore we have to drop all row wise and then look into only columns. When we look into column, that variable B1 B0 is common for all these 4 mapping. Therefore we'll just write B1 B0. Both are 1 1. Therefore let leave it as B1 and B0. So B1 and B0. These two becomes the expression. When we add together, this becomes the expression. So E1 equal to B1 bar B0 bar is one term plus B1 B0 is a second term. So this becomes the expression for E1. In the same way, let us do for E0. Same B3, B2, B1, B0, same 4 variables, but we'll be plotting for E0. What are all the mapping that we have to do? At M0 we have 1, 0, 1, 0. So 1, 0, 1, 0. 1, 0, 1, 0. So again 1, 0, 1, 0. And last we have 1 and 0. We have 1 and 0. And for the rest of the terms we are marking with don't cares. And again, by looking into this KMap, we can see that we have 2 possibilities of grouping. Let us write the expression for one by one. For the one first highlighted with green color, what happens? As said earlier, there is no common variable available. Therefore, we have to choose only these 2. Therefore, B1 bar, B0 bar. B1 bar, B0 bar becomes the expression. And similarly, for this group, there is no term available in common in row wise. We have to consider only columns. Therefore, it is B1 B0 bar because it is 1 and 0. Therefore, B1 B0 bar. B1 B0 bar becomes the expression. Therefore, we have to just write with a plus symbol B1 bar B0 bar plus B1 B0 bar becomes the expression for E0. So, right now, what did we do? We just had a question to convert BCD to XS3. We prepared a truth table. From the truth table, we tried to plot KMap and try to derive some expression for E3, E2, E1 and E0. So step 1 of truth table and step 2 of deriving KMap for every output variable is done. Now this is the third table, which is nothing but PAL program table. In order to achieve this table, first we have to understand what are all the product terms available in your expression. So we have 4 expressions here, E3, E2, E1, E0. We have to write down all the expressions and then find every term. We have one product term B2, B0. So we are writing B2, B0. There is another term B2, B1. B2, B1. There is a third term B3. Third term B3. Similarly, we have to find whether this B2, B0 is somewhere repeated here. B2, B0. B2, B0. Here it is B2 bar, B0. Therefore, it is a different term. So, therefore, this term is not repeated. Similarly, B2, B1. We have to find for B2, B1. No, it is not repeated. We don't have B3 also. So, we are writing as such. And here is the fourth term B2, B1 bar, B0. B2, B1 bar, B0. And similarly B2 bar, B1. B2 bar, B1. B2 bar, B0. B2 bar, B0. Similarly, we have B1 bar, B0 bar. When we look into B1 bar, B0 bar is repeated twice. B1 bar, B0 bar. Therefore, it is enough to write only once. So, we are writing B1 bar, B0 bar and dropping this term. And what is this term here? It is B1, B0. So, B1, B0. And as discussed, we are dropping this term because we have already written B1 bar, B0 in the product term list. Therefore, we will drop this one and move for B1, B0 bar. B1, B0 bar. None of these terms should be repetitive. And now, we have to make a table having all inputs B3, B2, B1, B0 and all outputs E3, E2, E1, E0. So, while looking into this product term, what are all the terms that we have? We have B2 and we have B0. We don't have B1 and B3. So, put a hyphen. And similarly, in the second product term, what are the variables we have? We have B2 and B1. So, we have B2, we have B1. So let us mark with a hyphen for the rest of the variable. Here we have only B3. So B3 is only variable available. So let us mark a hyphen for the rest of the variables. Here we have B2, therefore 1 for B2. B1 bar, therefore B1 is there but in its inverted form, so it is 0. Similarly B0 is there, again its complemented version, therefore it is 0. We don't have the term B3, therefore for the variable B3 we are making out a hyphen. Similarly for B2 bar, therefore it in its complement form, so it is 0. B1 is as such, therefore 1, the rest of the variables are not there, therefore let us mark with a hyphen. In the same way we have to do for rest of these product terms. We have to map it based on the input variables that are available in the product term, whether it is as such or in its complemented form. And now we have to jump into the output table. So now let us map it. What are all the product term that E3 has? E3 has B2 B0. We have B2 B0. Therefore we need that in the output expression E3. Therefore I am marking with a 1. And similarly we have B2 B1. We have B2 B1. We need that term in the output. And the third term is B3. We need B3, this product term. So all these three together forms the expression for E3. And we are all going to implement it using only true logic, not its complemented version. Therefore we are making it as T. And similarly for E2, what are the three terms that it has? B2, B1 bar, B0 bar, B2 bar B1 and B2 bar B0. Here is the expression, and all these three product terms we need. So this becomes the expression for E2. Similarly for E1 it is B1 bar B0. So B1 bar B0 plus B1 B0 plus B1 B0. So this 2 becomes the expression for E1. And what about for E0? E0 we need B1 bar B0, which has already been mentioned here. So B1 bar B0 and similarly B1 B0 bar. This 2 becomes the expression for E0. Therefore all we are going to implement using only true logic, not the complemented version. Therefore we are marking it as T. Right now let us implement the same using a PAL. So we very well know that we can program only AND gates and OR gates have been fixed. So now what are all the input variables we have? We have B3, we have B2, we have B1, similarly we have B0. And if we have B3, then we will have its complemented version B3 bar, B2 bar, B1 bar and B0 bar. The same content is being repeated here. B3, B3 complement, B2, B2 complement, B1, B1 complement, B0, B0 complement. So all these are the possible inputs. In order to attain this input, we should use a NOT gate. Therefore, if we give B3, the direct form will be B3, the inverted form will be B3 complement. And similarly, if we feed in B2, the direct form will be B2 and the inverted version, that is your complement version, will be B2 complement. And similarly for B1 and similarly for B0. Therefore, all the inputs are ready. Right now, we have to plot in order to achieve E0. So, what are the expression for E0? We know that E0 is equal to B1 bar, B0 bar plus B1, B0 bar. This is the expression for E0. Therefore, B1 bar, B0 bar, we have to make a cross mark. B1 bar, B0 bar. It gives one product term. So B1 bar, B0 bar. What is the next product term? B1, B0 bar. So B1, B0 bar. So this gives B1, B0 bar. We have to just give it to an OR gate. Therefore, these two terms are given to an OR gate, which gives us E0. In the same way, we have to program for E1, E2 and E3. Now, while programming for E1, what is the expression for E1? E1 is nothing but B1 bar, B0 bar plus B1, B0. So, B1 bar, therefore this is B1 bar and B0 bar. So, this AND gate will give the product term B1 bar, B0 bar, and here is the next product term B1, B0. So B1 and with B0, B1 and with B0. When these two product terms are fed together to an OR gate, that will give us the result E1. We can achieve E1. In the same way, we have to program for E2. So we know that the expression for E2 is B2, B1 bar, B0 bar plus B2 bar, B1 plus B2 bar, B0. Therefore, we need 3 product terms, therefore 3 AND gates. So the first AND gate, we can create a link between B2 and for B1 bar and B0 bar. That will give the first product term. So B2, B1 bar, B0 bar. And here is a second product term, B2 bar, B1. So B2 bar, B1. So this gives B2 bar, B1. And the third product term is B2 bar, B0. So B2 bar, B0. This will give B2 bar, B0. When all these 3 product terms are fed together to an OR gate, we'll get the expression for E2. In the same way, let us try to plot for E3. So what is the expression for E3? E3 is equal to B2, B0 plus B2, B1 plus B3. So when we look into first term is B2, B0. So therefore B2, B0. First term is over. The second product term is B2, B1, B2, B1, and third term is just B3. And right now we have 3 product terms, B2, B0, B2, B1 and B3. We have to give all these 3 together to an OR gate and obtain E3. Therefore, we try to implement the complete conversion logic in a PAL. I hope the explanation was clear. Thanks for watching the video.